Good morning, students and other viewers of this YouTube page or YouTube video. Today's objective is to identify the uh, the characteristics of even and odd numbers and go a little bit beyond the primary concept of it and go up to the intermediate grades of fifth and sixth grade, mostly of identifying it. And of course, we have the basic concepts that we know from the primary level, which is even numbers are ones that have all the units have pairs, and there's no individual units like these little dots here. None of these individual units have unit that's by itself, and an odd number, on the other hand, would be by itself. And so that is the main distinction between the two. The other thing that I think, well, actually, I think it goes a little bit beyond the second and third grade is that and it's formulaic. It's not really the science behind even and odd numbers, but when we're talking about larger numbers, because unfortunately, I think a lot of the times when we hear about, well, even numbers are 2, 4, 6, and 8. And then when people get to 12, then we forget about them and we don't understand, and I see it. I see it with fourth graders. I see it with fifth graders. I'll ask them and I'll show them a number that's like 23 or 24, and they can't tell you if it's even or odd. It's even scarier when you get to the really large numbers. So, especially when you have like two digits that are clearly odd digits, and that's another distinction that's difficult is students is that often when if your teacher gives you a number that is say 312, it has two digits that are odd, so you're like, what is it? Well, it's this last digit, and so this is what they mean by last. It would be the last number that you would hear. Obviously, when you say 12, you hear these two place values at once, but not always, because sometimes, like if, let's say we changed this digit here and said it was 2, then you'd hear 28, and 8 would be the last thing you would hear. It's also the last thing that you see when you're reading it. You read it here. And so it's the ones place that matters. Well, what about a decimal number? Well, decimal numbers are not considered odd or even because they are not whole numbers. So when we're talking about odds and evens, or even with fifth grade, you hear in sixth grade, you hear primes and composites used a lot. Odds and evens and primes and composites refer only to whole numbers and not to decimals and not to mixed numbers. So numbers with whole numbers with fractions are not considered odd or even either. It's really important to understand that distinction. So when we're looking for an even number, it ends in a 0, or that means it has a 0, a 2, a 4, a 6, or 8 in the ones place. So even it doesn't look at this one. You have mostly just odd digits, odd digit, odd digit, odd digit. Oh, there's an even digit. Then there's that even digit. And it doesn't matter what's in the tens place even. It's just this ones place that matters. No other place value matters. It's that last digit. And if it goes all the way past the decimal point into decimals, well, then automatically, boom, not even, not odd. It doesn't matter what it is. Even if it's a 0.2, meaning 2/10, it doesn't matter. It's not an even number. Even numbers are whole numbers, and it's only this ones place. So place value is important to understand, of course. We're saying the ones place is a 0, therefore it is an even number. Okay, so that is the basic part. And then as we were talking about odd numbers here. The primary concept is they don't have pairs. Also think of the Spanish. In Spanish, I like using that as a reference point because in Spanish, even is considered par, which also doesn't just mean even, but it also means a pair of something. And impar, I-M-P-A-R, is the Spanish word for odd number. which means literally not pair. So it's there's one unit that doesn't have a pair, and that's why it's odd. It's because it's missing a pair. And the beyond that, you have odd numbers that end with 1, 3, 5, 7, and 9, because the typical primary thing is, well, 1 is an odd number, 3 is an odd number, 5 is an odd number, 7 is an odd number, 9 is an odd number. But when you get to 11, there's a hesitation by many people. Some kids get it that, oh, okay, I'm looking at that last digit, but there's many that don't. And so I think that, guys, is the advancement here into the 5th grade and the 6th grade level, is now we need to be thinking about these larger numbers. Are they odd or even? And yes, if they're a whole number, they're either an odd or they're an even number. And this is how you judge it, because it doesn't matter how many even digits you have. It's that ones place, that last digit, that the thing you end with, that is the digit that matters. And interesting, just note that I'm saying digits, because there's only one number here. The number is 461. Notice the last word I said was 1, and that's the focus. But it's that whatever digit is in that ones place is what determines whether it's odd or even. So, but it is important to understand that the digits we're examining, that they're 1, 3, 5, 7, or 9, those are the odd digits. And then you have 0, 2, 4, 6, 8 for the even digits. But it's that ones place that determines it. So you can have 2, you can have a gazillion digits of the other type, but it's just this ones place. It doesn't matter that there's a 7 here and oh, well, that's an odd digit too. No, it's the 5 that here in this ones place that's determining it. It's the 7 in this ones place. This larger number, it's the 9, not the 1, not the 3, not this 3, that are determining it. Oh, well, it's mostly odd numbers, because that's a misconception that's often propagated. Well, there's mostly odd digits, so it must be odd. No, that doesn't matter, because you can have like nothing but even, and then boom, you have an odd digit in the ones place, and that's what determines all of it. And so that is really important. Now, the other thing that takes us, let's see if we're, oh, wait a minute, I missed a page. Let's see if I can find it. Oh, here it is. You have here the next concept that is typically more of an advanced concept, as opposed to second grade's concept of even and odd numbers, and that is the divisibility rule. And so when you're dividing an even number, it comes into two whole numbers with no remainder, no decimal. And that's when you know that the dividend, the number you're examining, is in fact an even number. So it's, don't be distracted by the quotient. Say, oh, but the quotient is odd. It doesn't matter if the quotient is odd. If you take two odd numbers and that are whole, you always get an even number. And so when you're dividing it by 2 here, you're going to get no remainder, and then you know, not this number, but you know that this number is even for certain, because there's no remainder, and there's no decimal or anything like that. Now, if you do the same thing, though, for an odd number, and you divide it by 2 as well, you will get a remainder. And, of course, but that means it's not an odd number either. No, that's the quotient. We're talking, because the quotient here, even though I have this number here, look down here, there's the remainder. Or, when you divide by 2, if you were to convert it into decimals, you would get a remainder of 5/10, and that's where it would stop. And that's when you divide by 2, because whenever you take any whole number and you divide it by 2, you always get either just the whole number, and that makes it even. Not the quotient, but the dividend is even. Or you get a quotient that has a decimal, and that decimal is going to be 0.5, or in other words, 5/10. It's going to be 5/10, and that means that the dividend is in fact an odd digit, because you divided it by 2 and you got that. and don't be distracted by this and say, oh, it's a decimal, so therefore it's not an odd. No, it's an odd number. We just added the decimal because you can always do that. You can always, you don't, when you get to the higher levels, guys, you're no longer going to be thinking remainder, remainder, remainder. You're going to be thinking fifth grade beyond. You guys are going to start thinking, oh no, we got to do decimal. We got to think of it in decimal. But this is still a whole number, even though we're examining it deeper. But this, because it has a remainder, or it has a 5/10 decimal for the quotient, that means that the dividend, the inside part here in this box, is clearly an odd number because it has a remainder 1 when it's divided by 2. It has a 5/10 remainder. It's clearly, therefore the dividend is odd because it's being divided by 2 and it's getting this result. Okay, and so that is the advanced understanding, that the science, you could say, behind this process of understanding what is an odd or an even. An even number is divisible by 2. And when we say divisible, mean that it equally splits up. It equally splits up with no remainder. And then when you have an odd number, there is a definite remainder. And it's always the same thing, a remainder 1 or 5/10. And that is the distinction, because you have 1 unit left over, 1 unit. And so that takes us to the even more advanced concept that is what we're usually tested by, because there are plenty of kids who understand all that stuff that we mentioned, all the stuff that's in the standards. Well, this is what the kids need to understand. But it comes down to it, it's these questions that show up on a standardized test or even on a unit test. These are the questions where they're like, oh, the kids don't understand any of it. And that's not true, because you do understand it. It's just that you need to watch out for this. You need to take the time to do the experiments, because they'll give you a scenario and they'll say, well, if you added, it's usually like a true or false question where they say, when you add 2 odd numbers together, it makes an even number, or it will say makes an odd number, true or false. And well, don't just be like, well, I guess, or I feel in my gut that it's this or that. Why don't you experiment? Take any 2 odd numbers and see what happens. So don't just take my word for it at these examples of like 1 plus 3 equals 4, and then you look at it and see, yeah, there's no extra pairs, there's no units without a pair here, so therefore it's even, and then, oh, well, that one works, but what about another number? You can take any number. 553 plus 787. You take 2 odd numbers. If you added those 2 large numbers, you'd get the same result. You get an even number. You get a number that ends in an even digit. Therefore, it's even. Or if you could, that'd be a large number, but you could draw out the dots on top of each other, and you would still have every single set circled and accounted for. And it doesn't matter how large it is, it would still work. So this is the concept. These are the kinds of questions that would show up on a test, a unit test. This is where that expectation, where the judgment is boom, it's on this concept. And then likewise, when you 2 even numbers, they still have pairs, because the one set of even numbers all have pairs. And then when you add them to another one that also has pairs, there's not going to be any loose units. So it's still going to be, so this is another one that shows up. And then, of course, the tricky one, and usually they'll say either odd number first or even number, but they'll say when you add one odd number to an even number, it will always make an odd number, because you have a number that, like 4, that has 2 sets of 2 that all have pairs, and then they add to an odd number that already has just 1 pair missing. Of course it's going to always come out odd, because you have a set with 1 loose and then the other one that has no loose, and so it's still going to have 1 with loose when you join the 2 together. So you take the number 2, like say let's take the first 2, that would be the number 2, so that's even. But then you take the number 13 and it's all the other ones mentioned up to this one, and you're still going to have that loose 1. So it doesn't matter how large it is, it would still do this. And so these are the main ones, and they might be worded differently, and don't let it fool you, true or false. Don't be like, well, my gut tells. No, Why don't you just experiment, write a few problems out, slow down, enjoy life a little bit, and really think about this while you're doing your math, and you will discover that this is true. So this is odds and evens and their characteristics for for these higher grades of 5 and 6th grade. So good luck. I'm sure you guys will do great on any assignments related to this. And you have a great day.